A very good morning to all my dear students. We were doing chapter electricity, and before we proceed in this chapter, let us revise what we have done in our last classes. In our last class, we have studied these following topics: charge, properties of charge, electric current, numericals, potential difference, and then the numericals related to the potential difference. Today we will study a new topic of this chapter. In Ohm's law was given in 1827 by a German physicist, George Simon Ohm. He found out a relationship between current and potential difference which exists between the terminals of any conductor. Let us see what he concluded from his experiment. According to the statement of Ohm's law, the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains same. This is the statement of Ohm's law, and whenever it is asked in the examination, this is the statement that you have to write in the examination. Many students, they write in short form that V is proportional to capital I, which is not correct, and it is not complete Ohm's law also. It is the mathematical form of Ohm's law. But if in the examination it is asked, define Ohm's law, then this is the statement that you have to write in your answer sheet. So this is the mathematical form of Ohm's law. V is proportional to I, and if we remove the proportionality sign, we get V equal to Ri. R, what is R here? R is a constant of proportionality and is called resistance. Ohm, Sir George Simon Ohm, he himself named this constant as resistance. Children, resistance is another very big topic in electric current, and we will be seeing that in our next class. But today, now we will see the circuit diagram of Ohm's law, which is very, very important. Children, this is the circuit diagram of Ohm's law. You can see here there are 6 electrical components which are connected in the circuit diagram. The first one is the battery B. The positive terminal of it is connected to the ammeter A. Then ammeter is connected to voltmeter, which is in parallelly connected to resistance R. Then we have rheostat, which is another name for rheostat is variable resistance. And lastly we have plug key, which is a dot is given, that means the key is closed. So children, when the plug key is closed, at that time the arrow should be drawn in the circuit diagram. These arrow tells that the current is flowing through the circuit. So just like in ray diagram, arrows are very important. Similarly in circuit diagram also, when the circuit is closed, the arrow should be marked, which tells that the current is flowing through the circuit. And the arrow is marked, its conventional direction, we have already studied this, that it is always from positive end to negative end. Beside the arrow, capital I is written, which is the symbol for current. So the arrow represents the flow of current through the conductor, and in this situation it represents the flow of current from the electric circuit. So this is the circuit diagram of Ohm's law. Ohm made this circuit, and on the basis of it, the 2 meters, we have voltmeter and ammeter. In the 2 meters, the value of potential difference and current was measured, and then it was written in an observation table. There is a graph is drawn between the potential difference and the current, and it comes out to be a straight line. which tells that V is proportional to I. So in your copy you will draw this circuit diagram of Ohm's law along with the statement of Ohm's law which we have discussed before. These two things you have to write in the copy, children. And in our next class we will be seeing some more questions or numericals related to Ohm's law. This formula is very important of Ohm's law. It will be used maximum in most of the numericals that you see in this chapter. So in our next class we will meet with some more numericals, children. Till then, copy the circuit diagram and write the statement. Thank you.